Hi everyone, this is Tom Yang. Welcome to Math at All. Today we'll be talking about one of the AMC topics, combinatorics. And more specifically, we're going to focus on circular permutation today. What is circular permutation? Well, circular permutation tells the number of ways to arrange n distinct objects around a fixed circle. And the number of ways to do that is n minus 1 factorial. That is circular permutation. There's n minus 1 number of ways to arrange n distinct objects around a fixed circle. Well, you probably, this expression might appear to be quite familiar to you if you've had some previous knowledge about combinatorics, because the number of ways to arrange n objects in a line is actually n factorial. They're quite similar. But why is there a difference between the two cases? We're going to talk about this today. Okay, so let's talk about the case where there's no circle. Okay, let's say there are 4 spots and we have 4 people. Call them A, B, C, and D. The number of ways to arrange these 4 people in those 4 spots that are in the form of a line is 4 times 3 times 2 times 1, right? Quite easy, which is 4 factorial, right? Well, now we are going to talk about a case where these 4 people are arranged, oh no, this looks bad, are arranged in a circle. Well, how many ways are there? Let's draw a table first. A table, it's a little ugly, but please bear with it. Okay, here's a table. And then we have 4 spots. And how many ways are there to arrange A, B, C, and D in those 4 spots around the table? Well, it's not exactly 4 factorial this time, and I'll talk about why. I'll make this smaller so that it doesn't really take over too much space. Okay, so let's say A is the first person to choose his spot, and he chooses here. And B chooses here after, C chooses here, and D chooses here. And then we'll have another case. Okay, I'm drawing another case. A sits here, B sits here, C sits here, and D sits here. And then another case, A sits here, B sits here, C sits here, and D sits here. And then another case. A sits here, B sits here, C sits here, and D sits here. Okay? Looking at those 4 cases, what do you notice? Well, you would probably notice that all these 4 cases are the same, right? You just simply rotate the table and get a seemingly different result, which is actually the same. Why? Because if you were to look at this table at a different angle, you'll get this, this, and this, right? It's just simply, you're just simply rotating the table, and the position of each person relative to another person is the same, right? See, A is beside B, B is beside C, A is beside B, B is beside C is beside D, and D goes back to A. Like, this kind of relative relationship is the same for all those 4 cases. So we say that these 4 cases are the same, right? And we don't want that. We actually don't want those all those 4 cases to be counted. We only need one of those to be counted, right? If you are simply using the formula 4 factorial, we're going to overcount, right? If we're going to overcount, and we don't want that. And in this case, where 4 people sit around a table, we're actually getting 4 times as many cases as I should. So I'm going to divide it by 4, right? These 4 cases are actually going to be 1 case. They are all the same, and I want to divide this 4 factorial by 4 so that all these 4 cases are going to be counted as 1 case, so I'm not going to overcount. Okay, if you're still a little confused, doesn't matter. I'll do this again. I'll interpret this in a different way so that you'll probably understand it more, I would say. So let me try to delete this. Oh no. Alright, I'll just delete the entire thing. Okay. So let me draw a table again. The core to circular permutation is relative relationship, right? It's relative. Like we're going to the thing that actually matters the most is the relative position between each person who sit adjacent to each other. So it doesn't really matter where the first person sits, right? Because let's say A sits here, okay, and I want B and C to be beside A, right? So B could be here and C could be here, and that is one case. And let's say if A is here, okay, A is here, and B is here, and C is here. The relative relationship between A and B and C is the same, right? It's the same. Their relative relationship is the same. C is beside A and B is beside A. And we're going to overcount if we don't eliminate one of the two cases here. So, and also that happens to if A sits here and B is here and C is here. And if A sits here and B is here and B is here and C is here. So it doesn't really matter where the first person picks his spot. It doesn't matter. It doesn't really matter. He only has one choice. I mean, he could choose all those 4 spots, but only one matters. Only one matters. If you're going to use all 4 cases, then you're going to be overcounting, because the relative relationship between each 2 adjacent people is the same, right? So if we were to use the method that we use to calculate the number of ways in the line, so if we use this way again, this way, there's only one choice for the first person, actually, right? There's only one person. We only care about relative position. There's only one choice for the first person to pick. And then, after the first person picks his spot, how many choices are there for the second person to pick? 3, right? 4 minus 1 is 3. How about the third person? 2, right? And we have 1 remaining spot for the last person. So it's going to be 3 times 2 times 1. And you probably would also notice that it's actually 4 minus 1 factorial, right? That's not 4 factorial, it's 4 minus 1 factorial. That corresponds to the formula for circular permutation, which is n minus 1 factorial. Okay, so yeah, here is the proof of this great mathematical phenomena. And I want all of you to actually understand the meaning behind it, the logic behind it, instead of just merely memorizing this formula, because you forget it easily if you don't actually understand it. And I hope that my explanation through this example will clarify this formula and probably demystify it, so that and I hope that all of you had fun and enjoy this video. Thanks for watching, and I'll see you next time. Bye.